Hi friends, today we are going to learn VRM sections of the laptop, that's called a CPU core voltages also. And here we can see the concept of how this CPU get the power. This one is the CPU, and this entire section is called the VRM section or the CPU core section, which generate CPU core voltage and the graphics core voltage, because the graphic chips also inside the processor. So, but before that, CPU should get these three voltages like 1.05, 1.5 and 1.8 from the different pulse width modulator. Once the CPU get all these voltages, then CPU received this signal that is called the VRM signal. This VRM signal you get either from SIO in Compal motherboard and Quanta motherboard, and in Westron motherboard and in Foxconn motherboard. This VRM signal generated by different sections. But CPU should get VRM signal that is supposed to be 1 volt and supposed to be 3 volt in some sections. Okay, so it's like that. So here we can see CPU required total 5 voltages, that is 1.05, 1.5 and 1.8, and then CPU core and graphics core. CPU core voltage is supposed to be approximately 1 volt and 30 amperes, and graphics core supposed to be 0.9 volt or 0.8, something like that, and supposed to be 10 to 15 ampere current. Okay, so CPU require the huge current, that is a 30 ampere current, so he is required 2 pulse width modulator. Here we can see the 2 pulse width modulator, and both voltage join together and reach to the processor. So this is the VRM chips, that is make of ISL 95863, and this chips require 2 powers to work, that is one is VIN voltage, that is 18 volt, and VCC voltage or the VDD voltage, that is a 5 volt. So he required 2 voltages to work. Then these are the pulse width modulator. These are the total 3 pulse width modulator we can see. This 2 for the CPU core and 1 for the graphics core. It's not necessary all the VRM sections have a 3 pulse width modulator. In some sections the graphics core generated by the different pulse width modulator, like that also. So but here we can take in single screen all this 2 sections together. Okay, so next is once the CPU got this power, this 3 voltages, the next is this VRM chip get the signal that is called a VRM signal, like this, that's supposed to be 3 volt, or now the latest motherboard in 1 volt. So you should get the VRM signal saying that turn on this pulse width modulator. Once you receive this signal, this VRM signal generate the pulses like this, trigger all this MOSFET. These are the MOSFET trigger. Here is 18 volt, that is VIN voltage. Here is 18 volt, and here is also 18 volt. This all voltage chop and trigger the MOSFET gates, and here is the pulsating AC voltage will be generated. Here is the pulsating AC voltage will be generated, and this goes to the different coils, and then coil stop the AC and pass the DC, which is filtered by this capacitor and reach to the processor. So this is my step 1 is power, step number 2 is VRM signal, step number 3 is this pulses, then step number 4 it should get the output voltage. You can see in this animation how this voltage is going and reach to the processor. So once the processor get the power from the VRM section, that is in current, that is in amperes, he send a signal that is called a SVID signal, that is called a serial voltage identification signal. This is a 2-wire communication protocols between the processors and the VRM sections. So he send this 2 signal saying what the level of current is required. If they require more current, he tell the VRM section I need a more current. So like that he can convey his message to the VRM section, that's called the VID signal. So once this voltage gets stabilized, the CPU core and graphics core is stabilized, that is supposed to be approximately 0.9 volt both 0.9 or 0.8 or 0.1 volt also. Okay, so once this voltage gets stabilized, then he send out one signal that is called the VRM power good, like this, that is 3 volt, and in this way this VRM core voltage is working. Now we'll see how to find the problem if the core voltage is not coming. If you have a motherboard in that the CPU core voltage is not coming, then first of all we'll see where you have to check the voltages. We'll see this. Suppose you have a motherboard like this, okay, and here you can check CPU core voltage and this coil, and the graphics core voltage at this coil. Okay, these are the CPU core and these are the graphics core. Suppose this voltage is not coming, and you can check in the DC power supply also. If the in DC power supply is current something 150 milliampere or something 250 milliampere, in between 150 and 250 milliampere, then your CPU core voltage is not generating. There are so many reasons this voltage is not generating. So you can check the voltage here. If the voltage is not coming here, then what you have to do is you have to first check this voltages, that is a V in voltage, that is 18 voltage, there is the adapter voltage, and then this 5 voltage, the VCC voltage. If these voltages are coming, then you have to check this VR on signal. Okay, you should get the VR on signal at this VR on pin at the chip, VRM chip. If this voltage is not coming, then you have to check why this voltage is not coming. You have to trace from where the signal is coming. I already told you that this VRM core voltage is coming from SIO in Compel motherboard and in Quanta motherboard. But if the motherboard is Wistron and Foxconn, this VRM core VR on signal generated by a different circuitry. So you have to trace that where this signal is coming from. Okay, so you should get voltage. If not coming, you trace this. If this VR core voltage is coming, VR on signal is coming, then what you have to do, you have to check in cold test whether all this MOSFET, whether they are working fine or not. You have to test on the multimeter and check the resistor and remove the processor, check whether any short circuit or there. You have to connect multimeter, keep multimeter on buzzer, connect ground probe to the ground and positive probe to this coil. Your resistance should be high. It should not show a low ohm resistance at here also and at here also. If the resistance is low, like 1 ohm or 2 ohm without the processor, or any, if the buzzer is coming, that means there is something short circuit. So you have to remove that short circuit. If there is a not short circuit, then connect the processor, check the resistance. The resistance should not 0 ohm, it should show something resistance. Okay, if this resistance is okay, then this CPU is not short. So if the CPU is okay and this both the signal, like both the voltages are okay on the VRM chip, and this signal is also coming at this VR on signal is coming, but still CPU core voltage is not generating, then that means this VRM chip may be the faulty. You have to replace this core chip. Okay, and this way you can solve the problem. So now we'll see on the schematic diagram how to check where are the test point. We open any schematic diagrams. Okay, we have the open ones, the schematic diagram. You can see in this schematic diagram, this is called the VRM section, this one is the Quanta motherboard, and this chip is called the VRM chip. Here this section is called the graphics core voltage is generated, that is 33 ampere, and here is the CPU core voltages. Okay, and first what you have to do is first I'll increase this. You can see in this chip is ISL 95835, and you have to check pin number 20, 18 volt. then pin number 19 5 volt, and pin number 26 5 volt. These are the three input powers to these chips. Sometimes there are only two powers, that is a VIN and VDD or VCC. So 18 volt and 5 volt, and in some, now in the latest motherboard there is only VCC voltage, that is a 5 volt only. So you have to check accordingly the pin according to the chip. And the next signal required to this VRM chip is called the VRM signal. This pin number 6, you should get here 3 volt. In some latest motherboard here is a 1 volt. So you get 3 volt here, that VRM signal command to the VRM section to turn on. Once this VRM section receive this VRM signal from the SIO, what he do is a trigger. There are the 3 pulse width modulator in this chips. One is for this graphics, this, and these are the 2 for the CPU. This one, this, and another one, this. So once he receive this signal, he trigger this MOSFET. This MOSFET is a CPU core voltage. Can draw here. This is a CPU core voltage. This he trigger from this 2 sections. He trigger, and here is a CPU core voltage we generated on the both the section, and this 2 sections connect each other. 2 sections connect here, and here you can find supposed to be 1 volt and something current you can't check here, but somewhere 1 volt, somewhere 0.8 volt or 0.9 volt, something like that. You should get a voltage over here. Okay, so and this voltage goes to the CPU. Once this voltage gets stabilized, the VRM section send a VID signal, that is called the VID signal, and this VID signal goes to this VRM chip. Now in this VID you can see pin number 5 and 3. These are the VID. This is called the SVID. This is called a serial voltage identification signal. The 2 signal, one is clock and data. This is a bidirectional. It communicate with the CPU. Okay, and once this voltage is stabilized, this VRM chip send out one signal that is called the power good. That signal is known as VRM power good. That's supposed to be 3 volt. If 3 volt comes out, that means the entire VRM sections working fine. So in this way we can see how can we check the voltage on this motherboard. You can check the motherboard on this here. These are the test point. These are the VRM chip, and this one is called, here you can check 0.9 volt, that is a CPU core, and here at junction of this MOSFET, there you can check the graphics core. Okay, that is also supposed to be a 0.9 volt. So in this way we can see how this VRM section is working. Thank you very much.